Okay, the pulsar at the center of the Crab Nebula rotates 33 times per second. The radius is about 10 kilometers. What force is required to keep an object on the surface? So here we have the nebula that rotates, and we see the radius is about 10,000 meters. The angular velocity is going to be 33 revolutions per second. And so we're trying to keep, let's say, a person on here. So we need to find the centripetal force, which is mass times velocity squared over r. But first we need to convert to radians per second. So we have our 33 revolutions over second times the 2 pi radians over 1 revolution, which is the conversion factor for this. And from there we can put that into the velocity, tangential velocity formula, which is the angular velocity times the radius. So let's see, we have 33 times 2 pi times the radius of 10,000 meters. So this velocity is going to be 2.07 times 10 to the 6th meters per second. So from there we can find the centripetal force that's going to hold that person down. So it's going to equal 2 times mass times velocity squared over the radius, which equals the mass times the centripetal acceleration. So if we put our numbers in, we have the 80 kilogram times the velocity we found squared over the 10,000 meters, which will give you 3.44 times 10 to the 10th power, and that's almost 3 billion newtons that would take to hold a person or object down on the nebula.